Hello friends, welcome to GSR ChemTube channel. In this class we are going to discuss about atomic structure chapter. In this, Bohr's model of atom. In 1913, one of the Rutherford's students, Niels Bohr, proposed a model of atom that was consistent with Rutherford's model and the quantum theory of radiation. He modified the problems and limitations associated with Rutherford's model of an atom. Here you see the important postulates from this Bohr's model of atom. Electrons revolve around the nucleus with different energy in concentric circular orbits called stationary orbits or stationary shells. These are denoted as K, L, M, N or 1, 2, 3, 4 and so on. So here, if you suppose this is the nucleus of an atom, electrons are revolving around the nucleus in these concentric circular paths which are called as stationary orbits. The electrons have the least energy in the K shell of an atom, followed by L shell and M shell and so on. That means electrons present in the K shell or nearest orbit to the nucleus having lowest energy, and electrons farther from the nucleus are having greater energies. As long as electrons revolve in the same circular orbit, energy is neither radiated or absorbed by electrons. That is why these orbits are known as stationary orbits. That means suppose an electron revolving in a particular orbit, its energy will be constant. It won't radiate energy or it won't absorb energy until and unless it is revolving in the same orbit. Energy of an electron changes only when it moves from one orbit to another orbit. Energy is absorbed when an electron jumps from an inner orbit to an outer orbit and vice versa. Energy changes during the electron jumps from one orbit to another orbit is given by the equation delta E is equal to E2 minus E1, that is equal to h nu, where E2 and E1 are energies of the higher orbit and lower orbit respectively, and delta E represents the energy difference between these two orbits. H is called Planck's constant and nu is the frequency of that energy or radiation emitted by that electron. Here are some defects in this Bohr's atomic model. Let us see those here. One of them is Bohr's theory could not explain the atomic spectra of higher elements such as helium, lithium, beryllium, boron, carbon and so on, which have more than one electron. That means this theory is limited for single electron species like hydrogen. Bohr's model could not explain even hydrogen spectrum obtained using high resolution spectroscopes. Each spectral line on high resolution was found to consist of two closely spaced lines. So this was not observed in Bohr's model. It was observed that in the presence of a magnetic field or electric field, each spectral line gets split up into closely spaced lines. This splitting of spectral lines in the presence of magnetic field is known as Gemmell effect. The splitting of spectral lines in the presence of electric field is known as Stark effect. These were not explained in Bohr's model of atom. That means Bohr could not explain about these two. Bohr's theory could not account for the formation of chemical bonds, distribution of electrons in the orbits. The systematic arrangement of electrons in different shells of an atom is called as electron configuration of that element. For writing the electron configuration of an atom, we should know the following points. Out of them, the first one is total number of electrons present in that atom, and second one, maximum number of electrons that can be accommodated in each shell of that atom. For this, Bohr and BURY together proposed certain rules for better understanding the electron configurations of atoms. Let us see those rules here. Out of them, the first one is the maximum number of electrons that can be accommodated in a shell is given by the formula 2n square, where n represents the number of the shell. According to this formula, maximum number of electrons that can be accommodated in the first shell is given by the formula 2n square. We substitute 1 in the place of n. we get 2. That means only 2 electrons can be accommodated maximum in the first shell. Similarly, maximum number of electrons that can be accommodated in the fourth shell is given by substituting 4 in place of n in the formula 2n square. We get it as 32. That means maximum 32 electrons can be accommodated in the fourth shell of any atom. Next point. The outermost shell of any atom cannot have more than 8 electrons even it has a capacity of holding more electrons. For example, if M shell is the outermost shell of an atom, it can accommodate a maximum of 8 electrons only, although it has a capacity of accommodating maximum 18 electrons. That means M shell is nothing but that is a third shell. So third shell maximum it can accommodate 18 electrons. But if it is the outermost shell of an atom, it will be having maximum 8 electrons only, even though its capacity is of 18. Next point, an atom becomes stable if its outermost shell has 8 electrons or if it has only one shell containing 2 electrons. Those elements we are calling as noble gases. They have 8 electrons in the outermost shell because they are stable. The penultimate shell can accommodate a maximum of 18 electrons. Here the term penultimate represents last but one. Means the second shell from outermost can accommodate maximum of 18 electrons. Next point, electrons do not enter into a new shell before the inner shell is completely filled. That means after filling the inner shells completely only, electrons enters into a new shell from outside. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.